we will show that the limit as xy approaches the origin 0, 0 of x squared y over x to the fourth plus y to the fourth does not exist. And we will do this by showing that the point xy heading to 0, 0 along two different paths will yield two different limits. So for our first path, we will take y to equal 0. So we'll take the point xy, which is approaching the origin, to be on the x-axis. Now we are allowed to let y equal 0, we're just not allowed to let both x and y equal 0, because the point xy is not allowed to be the origin, but y itself could be 0. So path 1, y equals 0. Then our limit becomes x squared y is 0, divided by x to the fourth plus y to the fourth is 0. And that's the limit of 0. X is not 0, so this denominator is not 0, but the numerator is 0 because it's x squared times 0, and the limit of 0 is 0. So that's path number 1 gives us a limit of 0. Now for path number 2, we will let the point xy approach 0, 0 along the parabola y equals x squared. So the point xy will approach 0, 0 along this path. So we have the limit as xy approaches the origin, where y is equal to x squared, and this fraction in that case becomes x squared times y is x squared, divided by x to the fourth plus, now I copied the problem wrong. This should have been a y squared. It didn't matter. It didn't matter here. It's still a 0, but it's going to matter here. So let's copy it correctly. It's x to the fourth plus y squared. So y squared, if y is equal to x squared, then y squared is equal to x squared squared, which of course is x to the fourth. And then this becomes the limit, with all this stuff here, xy goes to 0, 0, of on the top we have x squared times x squared, which is x to the fourth, and on the bottom we have x to the fourth plus x to the fourth, which is 2x to the fourth. And this is simply 1/2. The x to the fourths cancel, and the limit is 1/2. So we see that this limit is dependent on the path, and so therefore the limit does not exist. Two different paths yield two different answers, and in that circumstance, there is no limit.